Exercise 3J. Calculate the Maclaurin expansion to the third order for f of t equals e to the power minus t cos of 2t. Okay, so we're interested in third order, so it means you're gonna have three terms. Okay, so you're gonna have f of t being estimated by the sum of this term, f of 0 plus f prime of 0 times t plus f double prime of 0 t squared divided by 2 factorial. So working out the derivatives, as you can see, the second term has the first derivative, the third term the double. Okay, and our function is a product of two functions, e to the minus t times cos 2t. So we have to use the product rule, which is given by this. Okay, so we're gonna let f be equals to, okay, f prime is just minus e to the minus t. What about g? Cos of 2t, g prime is gonna be 1. It is going to be sine 2t times 2. But remember that the sign is negative. So now computing, so starting with the f prime, so you're going to have minus e to the power minus t cos 2t from g minus resulting from g prime to sine 2t and f being e to the power minus t. Yeah, so you fully simplify and you get this. So actually, yeah, you can factor out e to the power t. Okay, preparing for the second derivative. So the second derivative, it's a product again, e and this. So using the products rule again, you should obtain this. So the Maclaurin expansion, you have f of 0 giving you what? 1. Okay, and f prime of 0 times t giving you t, f double prime of 0 t squared of 2 factorial giving you this term, or your expansion should simplify to this. So let's go to the third one. Calculate the limit of this function as x tends to 0. Use the first three terms in the Maclaurin expansion of cos of 2x. So if you compute, you're gonna get indeterminate form, 0 by 0. So let's try factorization. Okay, it says here one must factorize. Actually, you can work out this at the side, the expansion, but remember, use first three terms. Okay, so working out the expansion for this, so you have to work out the, just like how we did here in number 1, so f prime at 0, f double prime at 0. Okay, so you should be able to find this cos 2x. So you're supposed to have 3 times because we used the first 3 times, the Maclaurin expansion of this. So the limit reaches to this, so you have 1 minus cos of this. Okay, so you can put it here and try to fully simplify. You're going to end up with this. Okay, and you take the limit of this, and not actually the limit, so you you will have to divide by x to the power 2. Okay, x to the power 2 divided by x to the power 2. So this will give you 1, this will give you 2. This will give you x to the power 2. Now take the limit, and your limit is 2. So on the graph of y is equals to 2 and x is equals to 0.